Hey there, welcome to the lesson on arc length and sector area. Don't be scared of it. It's just like if you knew the area of a circle, how would you find the area of a slice of pizza? Or if you knew the circumference of a circle using 2 pi r, how could you work out the length of just a slice, the edge of the pizza, the curved edge of the pizza? So there's formulas for it and they're in the formula booklet, so don't fret. So let's first quickly revise some parts of the circle. Kind of good to be aware of parts of the circle. A circle is a set of all points a fixed distance from a point called the circle center. So just basically pointing out that the circle, each point is a fixed distance from the center of the circle. Here's the center of the circle. Each point's the same distance. On the circumference is the same distance. Circumference is like the perimeter, but for circles. A line segment from the center to any point on the circle is called a radius. So from the center of the circle to the outside, that's called a radius. We denote the length of the radius by the letter R. The perimeter of the circle has got a special nickname and it's called the circumference. A line segment which joins any 2 points on the circle is called a chord. So that's an example of a chord. A diameter is also a chord. It's just a chord that happens to cut through the center. But it's just anything that connects 2 points on the circumference and goes through the circle. Chord which passes through the center of the circle is called a diameter. So remember, that's the radius. The diameter is 2 times the radius. We denote the length of the diameter with lowercase d and the radius with lowercase r. Circumference we tend to call uppercase C. An arc, which is what we're going to try to calculate the length of. An arc is a continuous part of the circle. The length of the arc is called the arc length. So that length of that purple curve bit is called an arc length. Because an arc is kind of like a curve, isn't it? Like a rainbow. And so the arc length is the length of the arc. Every arc has a corresponding sector. So sector is like a slice of pizza. Basically, that's the angle. Just move on. So if you were to label these ones, this one, you would label the center. Here's an example of a radius. This thing, I don't know if you remember them, they were called tangents. Kind of, we'll use them a little bit when we do calculus, maybe, tangents. That's called a chord. That little area there is called a segment. This is also a segment. That's a minor segment. This one's a major segment. This little purple length here is called an arc, and this area in here is called a sector. Alrighty. Just the thing you might need to remember is the total number of degrees in a full circle, in a full turn, is 360 degrees. Let's put a degree sign on there. Ooh, don't want it in yellow. 360 degrees. So remember, the total number of degrees in a circle is 360 degrees. That applies here. Circle, so remember to find the circle, circumference is 2 pi r. I don't know why the colours went funny. Let's go over it so it's a bit clearer. Circumference is 2 pi r. Some people think of it as pi times the diameter instead, but in the formula we use 2 pi r. So I'm going to actually cross out this one because this one's just going to confuse you, pi d, because the formula booklet doesn't have pi times the diameter. Diameter is 2 times the radius. That's why pi d is the same formula as 2 pi r. But I'm just going to leave it, so cross those ones out. I'm going to leave it that we only know 2 pi r because that's the one in our formula booklet. Area of a circle is pi r squared. Pi r squared is a formula for the area of the circle. So think square areas, they've got square units, so the area one has pi r squared. Circumference doesn't have square units, so it's just 2 pi r. Here's the radius, here's the diameter, but we deal with the radius mainly. So therefore, knowing that circumference is 2 pi r and area of a full circle is pi r squared, you could think the area of an arc length, so the length of an arc, like so this would be the length of the arc. Here we go. Is the fraction of the angle that they give you over 360. So the angle over 360 degrees, because angles are always out of 360 degrees. So theta over 360 times 2 pi r. So the 2 pi r just comes from this thing up here. So because basically it's not a full circle, but if that was, for example, 90 degrees, it'd be 90 over 360. Which is like a quarter of a circle. If that was 45 degrees, we'd put 45 degrees over 360 times 2 pi r, and we would be given the radius. The area, by same definition, is the angle over 360, but instead of times the circumference, we times it by pi r squared, which I'll put in red because above I've got pi r squared in red. So basically you do theta over 360 times the circumference if you want arc length. If you want the sector area, like the area inside the whole thing, then it's the angle over 360 times pi r squared instead. Easy enough. These are in the formula booklet. There you go, here the versions of the formula booklet. They're on page 6 of your formula booklet, so get familiar where everything is in your formula booklet. I'm just double checking I'm filming. Yeah, good. Okay, so we're almost done. Length of an arc. Length of the arc is theta over 360 times 2 pi r. Done. Theta is the angle and degrees, r is the radius, to even remind you of that. Just going to put that in a little circle so you can kind of see that's the formula because there's all this writing around it. So that's the length of the arc. Area of a sector is same thing, angle over 360 times pi r squared. Perfect. There are two formulas we're going to use. So you don't need to memorize them, you just need to know where to find them in the booklet. And there's a lot of formulas in the booklet, so you now need to get really familiar with where they are in the booklet. All right, find the, so if you don't have a copy of the formula booklet, make sure to get a copy of me, or if your teacher, if I'm not your teacher. So yeah, good. Find the perimeter of that. So this is just a regular circle. So we're just going to use circumference equals 2 pi r. So circumference is 2 pi r. Write the formula. Circumference is 2 pi r. That's in the formula booklet on the first page. So circumference equals 2 pi, and the radius is 3.25 because it goes halfway across. If they gave me the diameter, I would just halve it and I'd write out what the radius was, which would be half the diameter. But they gave us the radius. So radius is 3.25, 2 pi 3.25. Put it in the calculator just like that, and you get an unrounded answer of 20.42035. Oh, how to do pi again? I'm going to remind you. So to do pi, so to do this, go to a calculator page, go to, I'm not sure if you need to do multiply. I can't remember. 2 pi brackets 3.25. I'm going to check for you. 3.25 close bracket. Oh, 25 close brackets. Enter. No, you don't. So you don't need to put 2 times pi. You see, it puts it in there for you. It puts the dots, which is like multiply. So I just did 2 pi. You click on here, and you get pi. You also, that's also where you get e, which is something you use sometimes in our course too. Pi and e. Okay, escape. Let's get out of there. So I just did just 2 pi 3.25, and it got it for me. So they find the perimeter of, notice now they want you to find the perimeter of a slice of pizza. So to find the perimeter of a slice of pizza, you've got to get the arc length, which to get the arc length, I'm going to use theta over 360 times 2 pi r. And then I've got to add the two radiuses, so plus 12 plus 12, because the perimeter is not just the arc length. This is the arc length here, but I've also got to add that plus that, because the whole perimeter is that arc plus that length plus that length. Both of these lengths are 12, they're just the radius. So that's easy. That's why I have plus 12 plus 12, plus 12 plus 12. And here I'm calculating the arc length using the formula up here, theta over 360 times 2 pi r. And our radius is 12. So theta is 60, so 60 over 360 times 2 pi r plus the two radiuses, 12 plus 12, gives me 36 point blah blah, unrounded. Then to 3 sig figs, that'll be 36.6 centimeters. Notice there's no square on the units because we're just talking about perimeter, which is a length, not an area. Now find the area of each of the following figures. So remember, area of a circle, we use pi r squared. They didn't give me the radius though, they gave me the diameter. So if you want, you can work out the radius on the side, it'll be 8.96. Oops, I just wrote 8.92. Radius equals the diameter, 8.96, divided by 2, which gives me the 4.48. That's where the 4.48 came from. So work that out, radius, and write out what the radius is, 4.48, because you might make a mistake in working out the radius, so then they'll understand why you used it down here. So area is pi r squared. That's in the formula booklet on page 1 of the formula booklet, or the first page of wherever the formulas are. Pi, the radius is 4.48 squared, so I'll put it in brackets. Practice putting it in the calculator. Go straight to, oops, I don't need to go control. Let's get out of there. Okay, enter. So pi is down here. Go pi, select pi, put brackets, 4.48. You can do squared or you can do to the power of 2, same thing. Enter. And you get 63.050 dot dot dot. Then to 3 sig figs, that'll be 63.1 meters squared because we're talking about area. So that was the area of the whole thing. Now they want the area of the sector. So remember, for the arc length, we had to do that length plus the 2 radiuses. Area of the sector, you just purely use the area of the sector formula. There's nothing extra to add. So area of a sector is theta over 360 times pi r squared, which again, where does that come from? That comes from here, area of a sector, which is on page 6 of your formula booklet. So the angle is 60 again this time. The radius is 8. I always write out what the radius is. Theta over 360 times pi 8 squared. How would I put that in the calculator? I would go 60 like this, 60 over 360, and then I would do time, arrow to the side, and do times pi. Where's that pi? Pi there. Yeah. Pi. 8 brackets squared. Okay, that's how I would get that answer. 35.5103 dot dot dot. Then 3 sig figs, that'll be 35.5, and it's area, so centimeters this time, not meters, centimeters squared. Well done, and that's the end of the lesson.